All right. Moving on, people. Which notations represent hydrogen? So if I have hydrogen, hydrogen is element 1. So it has to have an atomic number of 1. That's not possible. That's not possible. That's not possible. That's not possible. This is possible. So I have 1 and 1 for my atomic number. It's all I can have for hydrogen. But the mass is different. So an isotope is something that is the same element, but it has a different number of neutrons, which makes it have a different mass. All right, naturally occurring gallium is a mixture of isotopes that contains 60.11% of Ga69, which has a mass of 68.93, and then 39.89% of gallium-71, which has a mass of 70.92. So which one is correct? I know I don't divide by 2, so I'm going to cross that off right away. I also know I don't divide by each other, so I'm going to cross that off right away. So I want to always do mass times abundance. So 68.93 times 60%. Well, you'll notice neither one of these are dividing by 100. That means I need to move the decimal over on my percentages. So this percentage is going to be times 0.6011. And then this one is going to be 0.39. There we go. So I quickly find it. This one, they didn't move over the decimals. Actually, oh my goodness, look at this one. They multiplied the percent by, they mixed, like they put this one with this one and this one with this one. So that's definitely wrong. All right, which list of symbols represents nonmetals only? So nonmetals means I'm looking for things over here on the right side of the periodic table. So BAL. Well, I already know aluminum is a metal, so no. Li, Be, those are metals. They're left side losers. All right, carbon, Si. Si is a metalloid, so nope. PSCl, there's my choice. All right, next one. In the formula XSO4, X could represent the element. All right, so right away I know SO4 is a polyatomic ion, so I'm going to go over to table E. Table E lists them all out for me, and I can figure out the charge. So SO4 has a -2 charge on it. So if SO4 is a -2 and you don't see a 2 down here, X must be a +2. So SO4 was the team. It stayed together. A +2 and a -2 canceled each other out. So I need to figure out which one of these is a +2. So aluminum is a +3. So we go over to each one of these. Aluminum is a +3, so that's not my choice. Argon is a noble gas. It doesn't react anyway, so that's not it. There we go. Magnesium is a +2. Sodium is a +1. So magnesium is definitely my choice. All right, what is the chemical formula for lead 4 oxide? So lead is Pb. The 4 tells me the lead has a charge of +4. Oxygen is O. Oxygen's charge is -2. Crisscross, Pb2O4. Now that is that can be reduced. So if it can be reduced, I should go ahead and reduce it. And you'll also see Pb2O4 isn't a choice. So PbO2 is what it would be if you reduced it. And there it is, choice 1. Okay, which statement describes the general trends in electronegativity and radius as the elements in period 2 are considered left to right? So as you go across the table, electronegativity definitely increases because as you go across, you're going from left side losers to right side gainers, and they're good at gaining because they're stronger at attracting electrons. And then the radius gets smaller as you go across, because as you go across, there's more and more protons in the nucleus pulling those electrons closer. So electronegativity goes up, atomic radius goes down. There's my choice. What is the percent composition by mass of nitrogen in NH42CO3? And it tells me, I don't even have to add that up. It tells me that the gram formula mass is 96. So I have to figure out how many nitrogens I have. So it's in parentheses. So the 2 times 1, 2 nitrogens. So I look up nitrogen's mass, and nitrogen is 14. So 14 and 14 is 28 over 96 times 100. So I can do the math. Where's my little calculator? I'm sure it's going to come out this 29 one because it's definitely not over half, and it's not that small either. So sometimes you can just see right away what your answer is going to be. But 28 divided by 96 times 100 gives me 29.16%. So there we go. All right, which type of reaction does this represent? So I've got Ki, that's a compound, and then I have F, that's an element, and F is knocking out the I. So I have a single replacement. I have one switch, so that's single replacement. All right, 39. Which formula represents a nonpolar molecule containing polar covalent bonds? That is a great question. So this question, you've got to look for the nonpolar molecule. So that means it has to be symmetrical. And then containing polar covalent bonds. So a polar covalent bond means that the electronegativity difference has to be greater than or equal to 0.5. So let's do some cross-offs right away. Nonpolar molecule, this is not symmetrical, this is not symmetrical. So those can't be my choice. And then I go over here to number 1. So I know both of these are nonpolar molecules. This is not a polar bond. An H and an H would have an electronegativity difference of 0. So that can't be it. Now, just to show you that it definitely is a polar bond, I'm going to go to the electronegativity and I'm going to look up carbon is a 2.6 and oxygen's a 3.4. So that means they're 0.8 apart. So that is definitely a polar bond. All right, so I got a polar bond right here, but overall it looks symmetrical, so it's a nonpolar molecule. That's the best question we've come to so far on this exam. All right, so here's the next one. Reaction reaches equilibrium at 100 degrees. The equation and graph of the reaction are below. So here's my reaction. And the graph shows that the reaction is at equilibrium after 60 seconds. So here's 60 seconds. So here it's at equilibrium and here it's at equilibrium. And I always remind myself, my rates are equal and my concentrations are constant. And the question says the graph shows that it's at equilibrium because the concentrations, I want the word constant. There it is. Okay. Given the balanced equation, which statement describes the changes in energy and bonding for the reactant? So, when I'm asked about energy, I remember that statement, BARF. And so when bonds are broken, energy is absorbed. And when bonds are formed, energy is released. So here I'm taking water and I'm breaking it. And I'm absorbing energy. So energy is absorbed but not formed. So energy is absorbed as the bonds are broken. There it is. I just go find it. That has come up on every single exam that we have done. This is our 5th, so 5 exams in a row. This question has come up in some way. All right, at standard pressure, what's the temperature at which a saturated solution of NH4Cl has a concentration of 60 grams per 100 grams of water? So that means I got to go to table G. So go to table G and find 60 grams. So table G, 60 grams. And then I want to go over to NH4Cl. So NH4Cl is right there. And then I go down. And that looks like it's around 65, 66. There we go. Which aqueous solution has the highest boiling point at standard pressure? They gave me different ionic compounds. And so remember this, like here's normal freezing and normal boiling. And if you add something ionic to it, it goes bloop. And so my freezing point goes down and my boiling point goes up. That's what happens. So which one is going to give me the highest boiling point? I want to add something ionic. These are all ionic. 1 molar versus 2 molar, I'm going to go for the 2. Add more moles and you're going to add more molecules and you're going to change it more. Now, KCl versus CaCl2. KCl would dissociate into 2 ions. You'd get a K plus and you'd get a Cl minus. CaCl2 would dissociate into 3 ions. You'd get Ca plus 2 and you'd get Cl minus 1 and another Cl minus 1. So I want to pick the one that has the highest concentration and the most ions. The most ions are going to give me the greatest change in my boiling point and my freezing point. All right, which change causes the equilibrium to shift? So I want to say which one is going to make it go to the left or to the right. So increasing pressure. Pressure only works on gases, not a gas, not a gas, not a gas. That will not work. All right, increasing temperature. If I increase temperature, I add here, which will make it shift away. That works. So there is my answer. If I look at the other choices, adding a noble gas, well, there's not a noble gas in this reaction, so why would that do anything? And adding a catalyst just makes the whole thing faster, forward and reverse, so that is not going to help shift it. Which hydrocarbon is saturated? The word saturated means that it has single bonds. And so if you're not sure, you can go back to table Q, and table Q shows you that single bonds are alkanes, and single bonds have the formula CN H2N plus 2. And there's the picture showing you single bonds. So I want to double plus 2 the H's. That's the same number, so that's not double plus 2. This is only one more, so that's not double plus 2. This is not double plus 2. This one is. So I wanted CN H2N plus 2. Which volume of 0.6 molar H2SO4 exactly neutralizes 100 milliliters of 0.3 molar BaOH? So I have an acid and a base here, and so I'm doing a titration. And so if I'm doing a titration, I can actually go on the reference table. In the back, it tells me which formula to use. So whenever you see a reaction with an acid and a base and molarity and volume, you want MAVA equals MBVB. So here's my formula, MAVA equals MBVB. And the volume of this acid, so 0.600, I'm going to find the volume of the acid, and the molarity of my base is 0.300, and the volume of my base is 100. So I'm going to divide this side by 0.6, divide this side by 0.6. So I've got 0.3 times 100 equals, divided by 0.6 equals 50. So I would need 50 milliliters. Okay. Given the formula for an organic compound, what is the name given to the group in the box? So all they're asking me about is in this box, 2 carbons. So I can go over here. I'm throwing my calculator around. All right, I'm going to go over here. Prefix for 2 carbons is F, and it's a branch. So ethyl, YL. There we go. All right, which type of matter is represented by the particle diagram? All right, I've got 2 different elements together, and it's in the same ratio. It's a fixed thing. This is a compound. Not a mixture. I only have one kind of thing. I have 2 different kinds of dots connected, so I have 2 elements connected forming a compound. Which one is an electrolyte? An electrolyte means that it can conduct electricity. So I'm looking for either an acid or a base or an ionic compound. So oxygen is not an acid or a base or an ionic. Xenon is a noble gas, so it's not an acid or a base. C3H8, that is pentane or a propane, so that's not an acid or a base. Here we go. KNO3. K means it has a metal, and the NO3 is covalently bonded, so this is both ionic and covalent, so that could conduct electricity as long as it's AQ. All right, which type of organic reaction produces both water and carbon dioxide? So what makes water and CO2? Addition reactions are the ones that have the double bond, and you just add two things together, so that doesn't make water and carbon dioxide. Combustion does. So combustion's burning, and so when you burn something, you always make carbon dioxide and water. Those are your two products. Esterification makes an ester, and fermenting makes alcohol. Ooh, we are done with the multiple choice, people.